Hello, everybody. Welcome to the session TDD, Test-Driven Drupal, by myself. My name is Oliver Davis. Uh, Thanks for everybody for just replying in the poll, the live poll. At the beginning, I can see a couple of comments coming in already, which is great. Thank you for some interaction. That's brilliant. What we're going to be doing in this talk, first we're talking about why to write tests and what to test, what different types of tests we have available to us in Drupal, how to run them. We'll look at a couple of examples and then also how to build a new module with TDD, depending how the time goes. My name is Oliver, as I said. I work for a company called Vika. I'm a full stack software developer and system administrator. I'm a long-time Drupal developer. I've been doing Drupal for about 13 years, 12 or 13 years, I think, according to my Drupal profile at this point. Here you'll see a link to my website. I do some blogging about Drupal and PHP and Tailwind CSS and various other things, as well as my Drupal.org page and my Twitter profile. So OP Davis pretty much everywhere online. So yeah, a little bit more about me. I write custom modules and themes for clients during my day job. I'm also a contributor to Drupal 8 and Drupal 7 core, and I maintain and contribute to various Drupal contrib projects. The most popular one at this point being override node options module. So I saw this tweet back in February 2012. Does anybody want to become a maintainer or co-maintainer of override node options? And I sort of left it the chance to take over that module. This was a good sort of reason for me wanting to start to learn how to write testing, how to do testing and write tests. So as I said, I became a maintainer in 2011. I checked these figures yesterday, and it's currently the 223rd most used module. It's gone down one place since I did this talk last for the last conference, although the number of sites has gone up. We're up to just over 31,500 websites using the module at this point. There were some existing tests. There was a Drupal 6 and Drupal 7 version when I took it over, and now there's Drupal 8 and Drupal 9 as well. But having these tests and maintaining these tests over time has been crucial to preventing regressions in the code and also just refactoring the code as we've gone along. There's been some quite large patches. One springs to mind that probably wouldn't have got committed if it wasn't for these tests. So this is the module page when I took it over. As I said, there's versions for Drupal 5, 6, and 7 right there. And at that time, you can see there's 9,401 sites using the module at that point. And yeah, mostly Drupal 6 and Drupal 7, as you'd expect. And yeah, just totaling just over 9,200 sites across those versions. This slightly out of date now, but yeah, 29,000 sites using it when I took this screenshot last. And that's over, there's still some Drupal 5 sites and some Drupal 6 sites, surprisingly. The vast majority is Drupal 7, and then just over almost 9,500 Drupal 8 installs of this module. So yeah, just under 30,000 install active sites when I took it over. So yes, why write tests? Catching bugs earlier. Yeah, I don't want to be shipping bugs to 30,000 websites whenever I do a release of this module, or to client websites for that example. And having these tests and having them run and passing and failing when I want them to gives me peace of mind. It makes me know that what I'm doing is right and that everything is working before I do a deploy, as long as everything's green. Preventing regressions. So if there's a bug that's been fixed or a feature that's been added, if there's a test that goes along with it, I'm confident that as long as if I make any further changes, I've not broken the functionality that I'd already added previously or the bug that I'd fixed previously, because there's a test there that tells me that it's still working as expected. Writing less code, I found if you take the test-driven development approach, you end up writing less code because you're only writing code that you need to write to make your test pass. So it's much cleaner, a lot more focused. And what you don't have to do is write a couple of lines. Maybe I need this, maybe I don't. you probably don't take it out again because it's working at that point. Yeah, the test-driven approach works wonders for me. And then documentation. The tests act as their own set of documentation. Particularly within Drupal 8, if I need to figure out how to do something, quite often I'll look at the tests for that module and figure out what it's doing there. It's a Drupal core requirement. So the testing gates for Drupal core require you to write tests either for new functionality or to prove that you fixed a bug. So usually you'll have to make one patch with a test that fails, and then another patch with the test that fails and the fix, so that the test is now passing. And this is even more important with regular Drupal 8 and Drupal 9 releases. So every 6 months now, we've got new versions of Drupal 8 and new versions of Drupal 9. And as a module maintainer, I'm having to support multiple versions across with the same module. So for Node Options 8.2 supports various versions of Drupal 8 and Drupal 9 at the same time, which is pretty cool. But yeah, it is some overhead. So as I mentioned, there is a core testing gate for core. So as I said, we just need to make sure that there are new tests when you're adding new features. If you're adding fixing a bug, we need to make sure that there's a test to show that the bug has been fixed. Make sure that existing tests still pass if you're going and making any changes. And yeah, again, if you're just making markup changes, yeah, browser tests and screenshots. Or providing an example module if there's a new feature that's not in core yet. So testing in Drupal 7, we had the simple test module that was provided as part of core. I believe it was there as a contrib module before that as well. And then over the course of the Drupal 8 lifecycle, PHP unit was added as a core dependency. And then later became the default. So PHP unit became the primary testing for Drupal 8, and simple test was phased out. And there was a PHP unit initiative that was converting tests from simple test cases to the PHP unit test cases. And then the plan was for Drupal 9 to remove simple test. I believe it was moved to contrib, and then all the tests now run through PHP directly. So how do we write tests in Drupal 8? The tests are their own PHP class with a .php extension. This is quite different to writing tests in Drupal 7, where they would have a .test extension. Yeah, in Drupal 8, they are using .php. There's a tests directory with its own source subject src directory, and this will live inside the module that you're writing tests for. The namespace is slightly different. So the Drupal namespace that we would use, followed by the module name. For tests, it's Drupal/test/module name. The class name needs to match the file name. The namespace must match the directory structure, and one test case per file. So again, in Drupal 7, it was pretty common to have multiple classes inside one .test file. But because of PSR4 autoloading, there needs to be one test class per file. So this is all pretty common PSR4 autoloading. So in terms of our tests themselves, there's 3 steps, usually 3, sometimes 2. And conveniently, they all start with letter A. So the first is to arrange, then we're going to act, and then we're going to write assertions. So if anyone's familiar with writing user stories, these will typically be given when then. Given that there's a user, when I go to a certain page, then I should get a particular response code, or given there's a node, when I run the thing, then something else should happen. My node gets deleted or something. So in this example, yeah, given the about page exists, when I go to the page, I should see the about me text. So this is quite useful if you're writing user stories with this sort of given when then format. And quite often I'll copy and paste these into my tests and just add them in as comments and then write the code around them. So yeah, given these are PHP classes, we need a namespace. So in this case here, we can see this is an example module. So it's inside the modules directory. It's called example. Module is called example. Then we have our test directory and our source directory. This is a functional test, so it's inside a functional directory. and then the name of our file, which is example test.php. So we'll see that the namespace matches the directory structure above. So it's inside a functional directory. I do that just to make things a bit clearer when I'm looking at the code, look at the module to see what's going on. But also we can then just say run all the functional tests in one go, or all the unit tests or the integration tests in one go. Then we have a class. So our class is just called example test. Our file was example test.php. And then we're going to extend a browser test base class. So the type of test just depends on what we're extending. So this one is a functional test or a browser test. So we're going to extend the browser test base. And then we have an actual test case, which is just a method, a public function inside this class. And they have to be starting with the word test. So the case is just test something. And inside there, we're going to add our given, when, then scenarios. And there's a few different ways that we could write our test functions. The one I just showed you is writing the word test as the prefix, and then using camel case, so capital S for something. We could also use an underscore and then use snake case as a test underscore something. Or we can drop the test prefix completely if we're using this annotation, the @test annotation. PHP Unit will pick up any of these three. I quite like the third one personally. That's pretty common in Laravel and some PHP projects. It sort of depends on how your coding standards are set up. Typically, Drupal CI will throw coding style violations for anything other than the first one, because it expects everything to be camel case function names. So here are some examples for some things that I tested on a project a couple of years ago now. So creating nodes from data with data from an API, calculating attendance figures for an event, determining if an event is purchasable. In this case, the event, you can only book onto an event from a certain window beforehand. Promotions and coupons for new users, cloning events. This is an event management based DrupalCon site, if anybody had noticed the similarity here. Queuing private message requests. We want to be able to message all the attendees on an event. So that was private message module. So we started queuing those because some of these events had lots of people on them. Emailing new members. They had support ticket functionality. So when a support ticket was closed and then reopened, when they added a comment to it, we wanted to reopen the ticket. And then there's some custom form validation rules that we added as well. So these are just some examples of some things I tested on this event management project that I did. And yeah, this is a tweet that I saw from Laravel Live a few years ago. The number one test that you should write should be the one that you would use your job for if it broke. Yes, anything that gives you that peace of mind. Again, you don't want to be woken up at midnight on a Friday or 5 o'clock on a Friday, just to, oh, that thing needs fixing right now. So there are a few different types of tests. Functional tests we've already talked a little bit about. There are also functional JavaScript tests. So these are typically called web or browser or feature tests. Kernel tests, again, these are typically also called integration tests. And then unit tests. So these are commonly what people think or associate with PHP unit is unit testing. But yeah, we're using all three of these or four of those within PHP unit in Drupal 8 and 9. So functional tests test end-to-end functionality. So they're actually booting up a browser behind the scenes, making HTTP requests against the URL that you're serving locally, and be able to check the response codes and the text returned back and everything else. So we're actually doing full browser testing here. It interacts with the database. So we've got a fully bootstrapped Drupal website. So we have access to a database. So we can use real nodes and real users and real everything. That said, full Drupal installation. It is using a testing profile. There's a testing, if you look inside the core profiles directory, there's a testing profile. I think there's a few of them now. So it's not doing a full standard Drupal installation. It is using a particular profile. Because of this, these are slower to run. It's having to make actual requests and get the responses back from your web server. And as I said, there are versions for with and without JavaScript, just depending on which base class that you extend. So here's an example of a functional test. This comes from the block module. So you can see we've got a block test to extending a base block test base class. And we're going to test the visibility of a block. So we're making a new block here with a block name, which is powered by. It's using a helper here to set a random machine name. We're getting some configuration values out here, or the default theme from the configuration values. And yeah, just this is our arrange step, is creating our block and configuring out how we want our block to work here. And then we can see here we've got Drupal get. So this is the Drupal helper for making get requests. So go to this page, go to admin structure block, add block name, and store the result there. And then we've got insertions. So we're going to check that the field exists. We're going to assert that the field exists. We're going to do a post request to the page. We're going to click on the button that says save block. And then we're going to check that the text, the block configuration was saved on that page. So very high level UI, go to this page, click this button, does this text exist? Kernel test to the next level down. So you can still create, still install modules. We can still interact with services and our service container and the database. But it's an even lower level Drupal bootstrap. So there's no browser, there's no HTTP requests, which is great because it makes it faster than the functional ones. But we do need to do some more setup steps to make it work. So here's another example from the block module. We're extending a kernel test base class this time. You can see now that we've got some extra lines in here. So we've got this container get theme installer, and then we're going to install the themes, and we're going to set some configuration values. We didn't need to do this in the functional test. It sort of does this for you, installs the configuration for the modules by default, for example. And then the test method here, we're going to rebuild blocks. We're going to call the block rebuild. We're able to get the messenger service from the container and get all the messages from it, then delete them, and then just make sure that there's no messages returned. So no browser testing, no go to this page, check the response code. We're one level below that. We're testing Drupal code at this point, but yeah, we still have access to these services like the messenger again. Unit tests don't have the Drupal knowledge layer. So this is just testing PHP logic on its own. So there's no database interaction at all. We can't say get that service or say this node to the database. But these are super fast to run. These will run in milliseconds rather than seconds or sometimes minutes. But because of this, we do need to mock dependencies. And because of mocking, we can get very tightly coupled to our code. So mocking, because we can't use a real node, we could make a fake node essentially and say that this method should return this value and this method should return that value. And this method can be called 3 times in this bit of code. That's what I mean by tightly coupled, is if we then refactor that code, there we go, can be hard to refactor, then maybe we're not calling that method 3 times anymore. And even though the functionality still works, the tests are now failing because the very tightly coupled count of number of methods is no longer matching. So yeah, one final block module example here. So this is using a unit test case this time. And yeah, you can see about a third of the way down there, we can see this get mock for a block interface. So we've not got a real block, we've got a mocked block, fake block at this point. You can see it, we're expecting the method access to be called once, and that will return a specific value. So we're telling it explicitly here what to return, and we can write assertions against it. So yeah, there's 3 set there. This method expects to be called and return something specific. And see then, yeah, then right at the bottom here, we've got an assertion to make sure that the expected block equals the results. So we can see, just thinking back to the functional test example, like how much more setup is needed and how much more tightly coupled to the code is this one is compared to the original one. So let's talk about an example. This is another site that another project I worked on, again, a few years ago. We had to do an integration with a project with it's a service, called Broadbean. So it's a recruitment-based service that we can use to pull job nodes. So we were working on a Drupal project, and the client was creating jobs, or somebody was creating jobs in Broadbean, and we wanted to be able to display those on the website. So we wanted to create nodes in Drupal based on the data coming from the Broadbean API. There's an application URL that the user would click. I want to apply for this job, and it would link them off to another application again. So we weren't handling the job applications on the website. Those are handled elsewhere. Jobs had to be linked to offices. So someone could go to the office for Cardiff or Bristol or London, and they wanted to see the jobs that are assigned to that office. Job lengths are specified by a number of days. And they want to be able to specify in advance what the path would be. So go to /mycooljob, and they wanted to be able to do that on the Broadbean side. They wanted to map that path from a field in the API to something in Drupal. And the application URL was interesting. We had to construct it ourselves from the domain name that we're using. They passed to a role ID, the job role, as a get parameter, and there were various optional UTM parameters for tracking they passed through as well. So we needed to take all these things and combine them into one URL. So yeah, this is the process. So Broadbean would pass XML to Drupal, and then Drupal would build the application URL, and then the user would click that and go to the CRM. So how did we do this? We added a route to accept data from the API from XML, with XML. We added a system user with a particular role for API to authenticate against, for Broadbean to authenticate against. Active for values, the number of days that the job advert was active for, we had to convert to a timestamp, so we could save it in Drupal and essentially hide it and unpublish the node once it was passed. Branch name and locations were converted from plain text, because XML, to entity references. So we had a reference to the branch name and offices and locations as well. So I think the branch names are node and locations were taxonomies. So you want to be able to actually link those together. So we could do the give me all the jobs in this location or this branch. And yes, the URL alias that they define on the Broadbean side, we mapped to the path value in Drupal, so we were able to map it. So here's an example. This, I think, actually comes straight from their documentation, or maybe not. Think about it. No, this does come from the documentation. So this is an array, at least, or from the XML. So you can see here there's a command. So we're going to add this job. There was some authentication details there. This job is active for a year, so 365 days. There's an address. Our branch name is the one we need to convert to our entity reference field. The job title would be used as the node title. The keywords, again, we'd split by comma separated lists and store them as multiple values, text fields. And yeah, the role ID is the one that would get passed through as the parameter as well. And yeah, finally, the URL alias is the one that we'd store against the path to make it be available on that URL. So if there wasn't an error, we'd create the node and we'd return a response to the Broadbean API just to tell them that everything had been okay. And if there was an exception thrown, we'd return a particular error code and then return that back to them. So we did have a few issues where the wrong job branch was specified, for example. So we couldn't find a branch for that branch name didn't exist. So we threw an exception and threw that back to them. So how did that break down in terms of types of test? So functional tests, job nodes are created with the right URL. So given they've said we want it to be on /job123, can we actually go to that URL and get the right response code? Given some hosting issues and limitations, the UTM parameters were stripped. So we initially had just normal functional tests for this. These were passing. When we put it onto the staging environment, we realized that it didn't work, even though our tests were passing locally. So we ended up having to get around it with JavaScript and do some fun JavaScript things. So initially I was a bit skeptical of doing this, but then there's a functional JavaScript test. So I was able to run the test with JavaScript and just tweak the test slightly and be confident that it was still going to work as expected. So kernel test, just to check that the job nodes had been added and deleted. If the job was expired, that it should be deleted from the system. Just that our application URL had been generated correctly as well. And then we use unit tests to make sure the number of days, so 365 in this example, were converted to timestamps correctly. So given they tell us is 30 days, this is what the timestamp should be. So results, so we had no bugs at all. So this is very much a best case scenario. Just writing tests doesn't mean you won't get any bugs, but in this case we didn't, which was pretty awesome. There were some queries, there were some issues that we had, but these were really easy to identify sort of what had happened. It turned out, I think, that the form on the XML side had broken, so values being passed as the wrong field name or something. But this was quite easy to figure this out because we had the tests and we said that as long as you're sending us this data, then things will work. And they were able to go back and figure out what the issue was. So yeah, even though we'd spent a bit of time writing these tests up front, the debugging time that we had was reduced significantly, actually. And then yeah, any additional bugs that we find, we'd have gone back and added some more tests to prevent those regressions coming back in. So running tests, okay. There's a file in call called runtest.sh. This has typically been used, this has been there since Drupal 7 days. And this is just a shell script we can use to run the tests. So we can just run all the tests. We can specify a particular module to run the tests for, or we can specify a particular class to run the tests, just a test for. Alternatively, we could just run PHP unit directly. Said all the tests in Drupal 8, they're all running PHP unit. So I just tend to call PHP unit directly. And depending how your particular project is set up, you might need to tweak some of these commands slightly. So in this case, we could go into our vendor directory and run the PHP unit command. Our PHP unit XML is inside the core directory. So there's a file there called PHP unit XML.dist, which is the template one. So if we were to change that and change it for our project, then we need to specify where that is. So it's inside the core directory. It's getting ignored by default, so you're not going to commit anything project specific, which is good. And then finally the path. So in this case, we're going to run the PHP unit example test from the examples module. So as I said, the PHP unit XML file is a prerequisite because this is what configures PHP unit. So it's needed to run some types of tests. So functional tests and I believe kernel tests need the PHP unit file. The unit tests are fine without it. And as I said, it's ignored by Git by default. So if you were to rename or copy the PHP XML.dist file, maybe your simple test base URL needs to change because that will change based on your project. You're going to want to copy that and change it. So yeah, we can just copy call PHP into XML.dist to call.php HTML. Yeah, so as I said, yeah, simple test base URL is the one that the tests are going to use and say, what's the URL I need to be making requests against to do the tests. So this is important because if you start trying to ping the wrong URL, then you're going to get the wrong response codes back and the wrong response text back. Simple test database, again, it's another one we need to configure. So the sites will need a database to install into. They won't use your normal one by default. So we can specify a simple test DB. So typically I'll use an SQLite database here, but you could use the MySQL one. And stop on a failure equals true is a command I'll quite frequently add either into the PHP unit XML or at the end of my PHP unit command, which is great because if you're doing the TDD approach, you hit the first error, you want it to stop, you want to then go and fix it and then run it again. So this is quite useful. Test-driven development. You can write tests without doing TDD, but this is just one sort of process or one approach to it. So firstly, we write a test. So you don't write any actual real implementation code at this point. Write the test first. Feels a bit strange, but you get used to it, I promise. The test is going to fail, right? Because you're saying go to a page that doesn't exist yet, or make a node for a type you don't have yet. So the test is going to fail. You then write some code. So you just write enough code to make the test pass. Just enough code to make it pass. The test passes, and you refactor. And for a single test, you're going to go through this loop various times. So you just want to write just enough code to make the test pass, and enough again to make it fail. And you're just constantly going through this loop. So you don't need to write all the tests up front. Yeah, you just want to write enough just to make one test fail, then you make it pass, then you make it fail, then you make it pass. And then once it's passing, yeah, maybe you've done something like return, just return an empty array just to make a test pass. That's fine. But then, yeah, oh, that's not going to work for this, for the next bit. So we'll refactor whilst everything's passing. And yeah, just repeat. So yeah, here's just a little diagram of that. Yeah, write the failing test, make it pass, refactor. So this is where you might hear people say about red and green. Red is failing, green is passing, and then sometimes blue for refactoring. Yeah, red, green, refactor. So this is my process for porting modules from Drupal 7 to Drupal 8. So I'd make a new branch, I'd add some tests if there were a test already, or I would update the tests, move the tests across to the new version. Write the code to make the test pass, do any refactoring, and repeat. So that's pretty much the TDD workflow that I just mentioned. This is how I typically go about writing tests. So I'll start with the functional test first. This is called the outside-in approach. And I quite like this because these are the ones that are probably the easiest to write, and they're also the ones that give you the most value. Like, does this page exist? Yes. Right, and that's quite important. If you're building a page, you want to make sure that page is accessible and you don't mess up any permissions or anything. Yeah, and then drop down to integration tests or unit test where you need to. So you might have a failing functional test because you want to go to a page, your page doesn't exist yet. So then you want to drop down to an integration level, make that pass, and then within doing that, you've actually fixed the functional test as well. Programming by wishful thinking is essentially write the code you wish you had. So you can say, I'm going to call this method or this class. I know it doesn't exist yet, but I'm going to write it as if it did, and then I'll go and write it afterwards. And yes, writing comments first and filling in the code. So if you've got this given when then scenario, I will quite commonly just copy that in, write the test around it, and then delete the code afterwards. And delete the comments afterwards, sorry. And sometimes as well, I write the assertions first. So if you think back to the beginning where I said about arrange act assert, quite often I'll start with the assertions and then think, what do I need to make? Okay, I'm saying there should be 3 articles here. Okay, I'm going to need some articles, and then work my way backwards. Okay, so let's have a look at an example of building a blog module. And this is our acceptance criteria. So as a site visitor, I want to see a list of articles, of published articles /blog. I want to see them ordered by the post date. So you want to see the most recent or newest ones at the top of the page. So my tasks are: ensure that the blog page exists, ensure that only published articles are shown, and ensure that they're in the correct order. So let's start with the functional test. Does the blog page exist? So in this case, you've got a module called my underscore module. So this matches our namespace and our directory structure. And we're going to start with that browser test base that we saw at the beginning. And then new for Drupal 9, or I think from Drupal 8.8 or 8.9, you also need to specify the default theme. So this is the theme that the testing profile is going to use to run the test against. So typically this is going to be the Stark theme. 9 times out of 10, I'll use the Stark theme. So we can write a test that tests that our page loads. Usually I'd use a bit more of a verbose name, but slides. And we're going to do a GET request to our blog page. There's a helper function here called assert session, and we can use that to just check what our status code is. So we expect the page to exist and be accessible. So we're expecting a 200 response code. and we're expecting our response to contain a h1 with the blog in it. So because we're following TDD, none of this exists yet. We do need to enable the modules. So we need to enable the module that we're writing, and also we know we need to enable the node module. When we run these tests, we're going to get a 404 because that piece doesn't exist yet. So we can get around this by making a routing file. So we can specify our path, which is /blog. We can create a controller and our title. Run it again, we're going to get a different error code. So as long as our code is moving, our different errors are changing, then we're making progress. So we've gone from 404 to 500. And that's because our blog page controller that we've said should exist doesn't. So we can make one. And because we haven't specified the method, it's going to call the underscore invoke function. And we're going to say it's going to return an array. So we'll return an empty array. And the test passes. So we've done enough to make a page return at the right path with the right error code, with the right status code even. So now we've done that, we can drop down to the kernel test level and we can start trying to load articles. So we'll use the repository pattern here. So we'll make an article repository test. We can extend the kernel entity kernel test space. There's various kernel test spaces we could extend, but as we're using entities, it makes sense to use the entity kernel test space. We're going to use a trait called node creation trait. And again, we can just define our modules that we're going to install. And we'll have a test for loading our articles. We can use a create node function that's added by the trait. We're going to get our repository from the container. Again, this doesn't exist yet. We're going to get the articles from it. And we're saying there should be one article. It should be an object. And the key here is going to be 1 because it's node 1. And the title should be test post. And we can do this because every time we run a new test, it's going to reinstall a fresh Drupal site for us. So we can confidently say this is always going to be node 1. If we run this, we've not got an article repository yet. We haven't made one. So we can make an article repository inside a source directory, inside a repository directory. And we need to add it as a service. So now we've done that again, our error is changing, we're making progress. So now we get our article repository is found, but there's no get all method on it. So let's make a get all method. Again, it's going to return an array. So let's just return an empty array. Because we return an empty array, our actual size is 0, right? It's an empty array, but we've said we should be expecting 1. So this makes us make our get all method more fully functional. So we can actually inject here the entity type manager interface, get the node storage and call load multiple on it. Again, this isn't like the best solution, but we're going to let the tests tell us that that's the case. But for now, this is just the minimum amount to get this to work. Because you've added a dependency, our service container doesn't know this yet. So we need to update our services. In this case, we'll just use auto wiring to inject the dependency. There are a couple of interesting ones. So we get this error because we need to install the filter configuration. And if you get something like this, we need to also install or tell it to install the node access table. Yeah, and that one's done. Just keeping an eye on the time here, just about coming up to time. We're nearly done. So now we're going to test the articles, only articles are returned. So now we've got past the configuration, the sort of setup errors, we can quickly add these additional tests. So we're going to make some pages and some articles. We're going to call the article repository again and get all the articles and say we should only get 3, but we've got 5 because we've said to load everything. So we're going to make our get all method. We're going to change it to use load by properties now and say only call them to have a type of article, only load them with a type of article. And again, only if published articles are returned. So we can make some with different statuses here. And again, we can say that there should be 3, but there's 5 because we haven't had any filters based on the status yet. So we'll do that. And then finally, let's just make sure that everything's in the right order. So when we're creating nodes, we can change the created time. And this is something that would be really tricky to do with a functional test because everything so far, we're just saying, does this text exist? So this is, if we were trying to check the ordering of them, this would get quite complicated. But in this case, we can just say, get our repository, get all the nodes from it, check the keys, and we want them returned in this specific order. So if we had 5, we want them to be in the order 3, 1, 2, 5, 4. Of course, they're not, because we haven't done anything to tell it that should be the case. So we get this slightly interesting error message here. Yeah, in order to do this, we can add a sort by created date method to our repository and return them. And before we return them, we can call UA sort and do our sorting there. Now everything passes again. So this example came from a workshop that I did for DrupalCon London back in March, and I did it for DrupalCon NYC recently as well. So yeah, if you want to see like the full process, there's a link coming up in a moment. And yeah, I did this talk for user group a couple of years ago. It's great to see comments like this afterwards. Yeah, saying, you know, after seeing your talk, you know, I've gone and written some tests and uncovered a bug, which is pretty awesome. And this is exactly the experience I had when I started writing tests. At the beginning, I found a bug and they wouldn't go back otherwise. So we're just up to time. There's a link here to the testing workshop note that I mentioned. It's got step-by-step how to build this block module out in more detail. I'm writing a book, I have been for some time, on and off, on testing in Drupal. And yeah, you also contact me through the website or through Twitter. And then yeah, given that there's any, you know, we're out of time, I'll go back and look for any questions in the chat and I'll reply them in text afterwards. So thanks everybody for attending the session. It's great to give this talk for DrupalCon. Great to be speaking again at DrupalCon. Yeah, hopefully get to see everybody actually in person at some point next year. That would be fantastic. Well, as soon as we can anyway. Cool. Thank you very much.